and thank you so much for stopping by my poster. My name is Angkana Phongphut. I am a PhD student at Chulalongkorn University, Department of Chemical Engineering. My advisor is Professor Mundern Pisanpong. Today I would like to present on the effect of type of clay mineral on acetylcholinesterase immobilization and application in biosensors. Food production has to be increased to feed increasing population, and pesticides are used to increase the productivity by means of pest and weed control. It affects the contamination of pesticides in the environment. We can detect the pesticide by GC or LC, but they are complicated to operate on-site or in-field detection, so that in this work we focus on finding the fast and reliable biosensor to detect the pesticide. In this work, we want to improve the part of bioreceptor for pesticide determination by acetylcholinesterase biosensor. And we are interested in clay mineral because clay minerals are strong mechanical and chemical stability, high surface area, and inexpensive material. The objective of this work to investigate the effect of type of clay minerals on electrochemical response and performance of biosensor for detect the carbonyls. Clay minerals were modified by amino group and gold nanoparticle, and then the enzyme was immobilized on the surface of clay gold nanoparticle and then was dropped on the surface of electrode and covered by the hydrogen solution. In this work, we use the different types of clay mineral, namely kaolinite, montmorillonite, bentonite, and sepiolite. They are different in the physical and chemical property. Figure 2 shows the same image of each clay mineral, and montmorillonite shows the high surface area, and Figure 3 shows the gold nanoparticle on the surface of clay mineral, and the main particle size is around 2 to 3 nanometers. Figure 4 and 5 show the enzyme loading and residual activity of the enzyme on clay mineral and clay gold nanocomposite. As you can see, gold nanoparticle can be enhance the enzyme loading and the enzyme residual activity. It was caused by the positive surface charge of the gold nanoparticle react with the negative charge of enzyme, and the gold nanoparticle with the small size have a high surface to volume ratio and high surface energy to provide the suitable enzyme immobilization. The figure 6 shows the cyclic watermogram of enzyme immobilization on the different electrodes. As the result show that the montmorillonite gold nanoparticle show the highest current response due to the highest enzyme loading and the enzyme residue activity. And the figure 7, the fabrication of biosensor was tested by carbaryl pesticide, and this graph shows two linear range of calibration curve, and the detection of this curve is 0.01 nanogram per mil. We can conclude that clay gold nanoparticle can improve the electrochemical response, and gold nanoparticle enhance the enzyme loading and residual activity, and can provide a biosensor to detect the carbaryl pesticide. I would like to say thank you for our organization to support this work. Thank you for your attention.